Hi, my name is Kiran Baburaj. Welcome to Career Campus Pro YouTube channel. Today we visualize the implementation of a queue using a linked list data structure. We will explore how this FIFO data structure works and see its operations in action. Let's start with an empty queue. In our implementation, we have two special pointers, the head pointer and a tail pointer. Now let's see how we can add elements to our queue through the Enqueue operation. First, we add the element A. Since this is our first element, both our head and tail pointers will point to it. Each node contains two parts, the data and a next pointer. The peek operation allows us to see the element at the head of the queue without removing it. We can see the element A is highlighted. Now let's continue adding more elements. We add the node B, C and D. The tail pointer updates with each new addition, while the head remains fixed in our first element. Each new node is connected to the previous one through the next pointer, forming our linked structure. Now we have our queue. Let's see how dequeue operations work. When we dequeue an element, we remove it from the front of the queue. When we removed the first two elements, the head pointer advances to the next node each time, while the tail pointer remains unchanged. The size counter decrements with each removal, keeping the track of the queue's current state. Since we have used the linked list, the queue can grow and shrink dynamically. The head pointer gives us the constant time access to the front element, and tail pointer allows for the constant time insertions at the back. Each node maintains its data and reference to the next node. This implementation demonstrates the efficiency and flexibility of using a linked list for queue operations, making it an excellent choice for many applications. Now let's implement a queue using linked list in Python. Let's start with the fundamental building blocks of our implementation. First, we have the node class, which forms the basic unit of our linked list structure. Each node contains two essential components, the data and the reference to the next node. The queue class sets up our core structure with three crucial attributes, head and tail pointers to track the front and back of the queue, and size counter to maintain the current number of elements. We also include utility methods like isEmpty, getSize and peek for the basic queue operations. So further, we can add elements to our queue through the Enqueue operation. This operation handles two scenarios. When the queue is empty, both the head and tail points to the new node. This is our special case for the first element. For all other cases, we link the new node to the current tail and update the tail pointer. This approach maintains the FIFO principle while keeping the operation at constant time complexity. The size counter incrementing at the end ensures we always know exactly how many elements are in the queue. Next, the dequeue operation handles removing elements from the front of the queue. First, we check if the queue is empty to avoid errors. If there are elements, we store the head's data before removing the node. This is the value we will return to the user. We then move the head pointer to the next node. An important edge case occurs when we remove the last element. We need to reset the tail pointer to none to maintain the consistency. Finally, we decrement the size counter and return the removed data. Let's summarize the crucial aspects of this implementation. Our operations all maintain order of one complexity, meaning Enqueue, dequeue, size checking, isEmpty operations all have the constant time regardless of the queue size. The dynamic memory allocation gives us unlimited queue size potential constrained by available memory. We have maintained the FIFO principle, which will be providing efficient node-based operations. This implementation is particularly ideal for scenarios where you need a flexible, unlimited size queue with consistent performance characteristics. If you found this video helpful, please don't forget to like and subscribe. Happy coding. Thank you.